everyone. So in this video we are going to discuss an important problem. So these type of problems have like come in the previous IMO and also in the Cambridge interview question. So let's and also we'll solve this problem with the help of conjugate numbers. I'll also discuss what are conjugate numbers, but let's get into the problem. So the problem is saying that find the first digit before and after the decimal point in this expansion, root over of 2 plus root over of 3 whole to the power 1980. Okay, so now you must be thinking that like if we expand this, like root 2 is irrational plus root 3 is irrational, and now there's some, I'm expanding it to the power 1980. How do I handle this expansion and get these digits? So what has been asked is, like, if you expand this thing, so it will look like something of this form, like a1 a2 dot dot dot, let's say ak, and then the decimal point starts, and then let's say b1 b2 and so on. So we want ak and b1. Okay, so that's what we want. Now what are conjugate numbers? So now coming to that, so the conjugate numbers are basically like if a, b and r are rational numbers. Okay, so they are rational numbers and such that like root over of r is irrational. Okay, sorry. So this is the condition. So then what we'll have is a plus b root over of r and a minus b root over of r. These two numbers will be said to be conjugate numbers. Okay, they are conjugate of each other. So now let's get started with the main problem. So how do we solve this problem? Now first of all, notice that there are no conjugate, like root 2 plus root 3, so it doesn't look like a conjugate number of this form, right? So how do we get it into a conjugate number? So basically what we can do is, like, we can square it up. Okay, so if we square root 2 plus root 3, so what we get, 5 plus 2 root over of 6. So we can write root 2 plus root 3 whole to the power 1980 as 5 plus 2 root over of 6, 990. Okay, so now we'll so now we have a conjugate, like we have this number a plus like b root over of r form, where a, b and r are all rationals, and root over of 6 is irrational, that you can very well see. Okay, so now what we'll do is we'll take the help of this conjugate number and we'll add it with it. So what do we mean is that, like, we'll add 5 plus 2 root over of 6 whole to the power 990 plus its conjugate, like 5 minus 2 root over of 6 whole to the power 990. Okay, now you can easily expand this with the help of the binomial theorem. Okay, so I'm not expanding it. Okay, so just use the binomial expansion and nothing else. So you'll notice that the odd powers, where the odd powers of, 2 root over of 6, whenever the powers of it are odd, so those there, basically what will happen is that the terms will match from this side and that side, but there will be a minus sign for the right hand side expansion. So they will cancel out, right? So all these odd powers will cancel out and the even powers will survive on both the sides, and they will get added up to give me something of the form like 2 times, like, let's say, m. Okay, and why? Because the same quantity is getting added from both the sides, like the even powers of the thing, like on the left hand side of this expansion and the right hand part of the expansion, right? So also I claim that m is an integer. Why? Because try to notice that the even powers, okay, so whenever like 2 root over of 6 is going into an even power, then only those terms will survive. Okay, so what is happening, root over of 6 to the power 4 or 2 or 6, anything, so ultimately that will be an integer, and 5 is also an integer. So ultimately you are going to get an integer there. Okay, so basically this expansion will be of this form, 2 times some integer, where let's say m belongs to the integer. Okay, so now what? So now try to understand that we have like added these two up, and their addition is 2 times m. Okay, so now if I, like, I want, what do I want? Like, I want this expansion, right? So decimal, if I expand that, whatever be the right hand side of the decimal point and what is the left hand side of the decimal point, right? So what we can do is, like, for that we have to get hold of the last digit of m, okay, or last digit of 2m, okay. So this number we have to, like, if we can get hold of this, this is an integer, okay. So basically if we can get hold of the last digit, and then we will subtract this, okay. Now we'll subtract that, but that's also not very simple, but we'll come to that, like, how can we subtract that without actually knowing what exactly the number is, okay. So I'm going to come to that, okay. First let's go ahead with this thing, that is 2 times m. So first of all, what is this m? Okay, so as I told you that when the even terms are surviving, right, so there you will be getting m. So basically if you look at here, so that will be like 990, okay, choose 0, 5 to the power 990 plus, right. So I mean that in this term, like 2 times root over of 6, its power is 0. So with 0 is also even. Now next one is 990, choose 2, 5 to the power 988, then 2 times root over of 6 whole square. So it basically gets to 2 square times 6 plus 990, 4, choose 4, and then 5 to the power 986, sorry, 986, and then 2 to the power 4 and 6 squared, and so on. It will continue, okay, till what the last one, which won't have any 5, okay. So that will be 990, choose 990, which is basically 1, and 5 to the power 0, and 2 to the this 2 root over of 6 whole to the power 990. So it makes like 2 to the power 990, and 6 to the power, so it's like 990 by 2, which is 495, okay. Now while I am multiplying, like I'm trying to figure out the last digit of 2m. So now if I multiply this with 2, so 2, 2, 2, so all these terms are getting multiplied with 2, okay, and here also, so 2. So now try to notice that if I want like if I have an integer, if I want the last digit of it, so what do we basically do? We divide by 10, whatever be the remainder, so that basically is the last digit of any number, okay. Any number, when we divide it by 10, the remainder is the last digit, right? So if we look at now 2m under modulo 10, so what do we see? So we see that these terms they have 5 as well as 2, and so they are all perfectly divisible by 10, right? So all these terms are perfectly divisible by 10 because all these terms, at least 1 2 is there, which has got multiplied, and 5 is also there, but I have to then consider the number which doesn't have any 5 in it, okay. So that means this will be congruent to 2 to the power 991 times 6 to the power 495 under modulo 10. So now this is very interesting, like any power of 6, if you divide it by 10, so again basically the last digit is also 6, because you can very always understand, like take any power of 6, its last digit is always 6, right? So then we can say that 2m is congruent to the 6 will give the last digit 6, and 2 to the power 991. Now the powers of 2, they get repeated at a cycle of 4, 2 4 8 6, and then again 2 4 8 6, 2 4 8 6. So now if you divide, if you divide 991 by 4, so that means if you divide 91 by 4, so the remainder is 3, okay. So if any number, if you want to divide it by 4 and get the remainder, so you just divide the last 2 digits, whatever the number is making, so that will give you the remainder, okay. So that is pretty simple, like using congruence relation. So now let's come to the main point here, that is the remainder will be 3. So 2486, 2486, and so on. Like finally, like the remainder is 3, so we'll end up with 8. So 8 modulo 10. So then finally we can see that 2m is congruent to 6, 8, 48. So 8 modulo 10. Okay. So we got the last digit of that is we didn't get the actual number 2m. Okay, it's very large. We are not going into that. So we got the last digit of 2m. Okay. So now how will this number look like? Let's now write it down here. So 5 plus 2 root over of 6 whole to the power 990 plus 5 minus 2 root over of 6 whole to the power 990. Okay, so now this is a number which is like, let's say that a1 a2 dot 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 till the last digit is, we know it's 8. Okay, and then since it's an integer, so it's like all 0 up after that. Okay, so now all we have to do is we have to subtract this number from this number. Okay, now try to understand that root over of 6 you can fairly like fairly calculate it out, because you know that root over of 2 is 1.414 and root over of 3 is 1.732. So you can multiply these with 2 and see where it's going. Like it will be like 4.89. Okay, so you can multiply this out. Okay, so when we are subtracting it from 5, so it's like 0.1 something. Okay, so now if you are taking this number to the power 990, 990, okay, 990, so then what will happen is like this number will be looking like 0.000 something, like there will be some zeros first. Okay, because what happens is between 0 and 1, if you take any number and make it higher and higher, so it becomes smaller and smaller, so it will be becoming a very small number. Okay, so it will look like something of this form, 0.000, and after that it doesn't matter what is there. Okay, why I'm coming to that, obviously all the way up to like it won't be 0, right? So at least like there will be a first non-zero term. Okay, so the first non-zero term, we are not bothered about what it is, why I'm going to say. So let's say that it's like, for example, okay, for example, let's say that it's 1 or either 7 or whatever. Okay, so now try to understand that when you are subtracting that number, okay, so that means 5 plus 2 root over of 6 whole to the power 990 will be then a1 a2 dot 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 8. Let's write those zeros because we need to subtract. So minus, okay, I'm writing in this form. Okay, minus this is 0 point, let's say 0 0 0. Okay, so after some zeros the non-zero term is there, let's say it's 7. Okay, and here again 0. So now try to understand that after this also I'll have digits. Okay, fine, so no problem, but now try to understand that what will happen. So 7, I don't know, again I'm saying that I'm just taking an example here. So now what will happen here, that is here you will be getting like whatever 3, or if this 7 changes to some other number like 8 also, then also you'll get 2 or whatever. Okay, so then what will happen is this series of 9 will start. So the 0 will get converted to 1 and this series of 9 will start, and it will continue all the way up till here, and then 1 will come here which will get subtracted with that 8, so giving you 7. And then again we are not concerned about what the rest of the integers will be. Okay, so mainly we were concerned about these two digits. Okay, and we got that. So that's the solution of this problem, and I hope you liked it and you learned. If you have learned anything from this, so please don't forget to put a like, and please do share it among your friends and others, so that they can also learn this way how to solve such problems. Because like if anyone is given such a problem, like it will be totally, I mean, they will be blanked out, okay, because I mean, usually we if we go in the direction of expansion and so on and so forth, so we will be totally lost. So yeah, that's it for this video. So thanks for watching, and keep watching and keep learning, and see you in the next one.